becomes the first derivative. Welcome to this video, and here we are going to differentiate a given function using the chain rule. How do we differentiate a function using the chain rule? Well, we have three examples here which we are going to solve using the chain rule. But before we get there, let us find the general form in which we can use the chain rule to differentiate a given function. So if you have a function of y u raised to a, then if you want to differentiate this function, the first derivative of that function is going to be equal to, we multiply the power by the function itself, that is a multiplied by u, and then we subtract 1 from the power. So that is going to be a minus 1. And then we multiply whatever we have gotten with the derivative of the function in the bracket. So let me have the brackets here. So the derivative of this is going to be du. So that's the general form in which we can solve, or we can differentiate a function using the chain rule. So again, how do you do it? If you have a function of u power a, then you're going to find the first derivative, which is y prime, is equals to, you multiply the function with the power, and then you write the power. We subtract 1 from the power, and then we find the derivative of what is inside the bracket. So that is the general format, the general way in which we find the derivative of a given function. So for us to understand better, let us do the following examples for us to really get a feel of what we have just discussed. So we have a function here of y, and we are supposed to find the first derivative of this function. So this is going to be y prime, or sometimes dy dx. That is the function of y with respect to x is going to be equal to, so the first thing we do is we take the power and multiply by the function. So that is going to be 3 multiplied by the function is x plus 1 cubed. So that is the first thing. But the power, we have to subtract it by 1. So we subtract 3 minus 1. And then we multiply that by du. Du means the derivative of what is inside the bracket. And of course, if you notice, 2x plus 1, the derivative is going to be 2, because the derivative of 2x is 2, and the derivative of a constant is always 0, and therefore you're going to have 1. So let us simplify this. It's going to be equal to 3 multiplied by x. So we have a 2 here. 2x plus 1 power 3 power 2, because 3 minus 1 is 2 multiplied by 2. If you multiply 2 by 3, then you have 6 into 2x plus 1 power 2, and that becomes the first derivative of our function right here. So let us get into the second example, which is kind of complicated, that is going to be very easy. Look at this. So the dy dx of our function is going to be equal to, so we take the power multiplied by the function, that is 3 into 3x cubed plus x squared. Then we subtract 1 from the power, 3 minus 1, and then we multiply whatever we got with the derivative of what is inside the bracket, and that is going to be 9x power 2 plus 2x. I think we can simplify further by multiplying, we can multiply 3 by this function here, and then we subtract 1 in the power, and by the end of the day we're going to have 3x cubed plus x squared raised to 2, and we multiply that by 3 multiplied by 9 is 27, x squared plus 3 multiplied by 2 is 6x, and that becomes the derivative of our function here. Looks very simple and very fast. So if you wish, you can also expand to find the simplest solution. Now let's get to the third one, which kind of looks complicated, but as you can see, we could treat it as a quotient because we have 1 over 3x minus 2x cubed. The whole of that we raise by 4. So we can treat it as a quotient, but for now we are going to use the chain rule to solve it. So for us to be able to use the chain rule to solve this problem, then we are going to write the function as follows. Y is equals to 3x minus 2x cubed raised to negative 4. So this negative 4, we have now the denominator becomes the numerator, and then we introduce a negative there. Alright, so we are ready now to solve using the chain rule. So the first derivative, therefore, we have some division here. So the first derivative, dy by dx, is going to be equal to, now we take the power, which is negative 4. We multiply that by the function, which is 3x minus 2x cubed. And then we are going to subtract 1 in the power, which is negative 4 minus 1. Then the result of this, we multiply by the derivative of what is in the bracket. The derivative of 3x is 3, minus the derivative of 2x cubed is 6x squared. That becomes the derivative, but you can simplify further. So this is going to be equal to negative 4 into 3x minus 2x cubed raised to negative 5, because a minus 4 minus 1 is a minus 5, multiplied by 3 minus 6x squared. So again, you notice we can make this a denominator and make this a positive. Therefore, the final derivative for y prime is going to look like this. It's going to be minus 4 multiplied by 3 minus 6x squared divided by 3x minus 2x cubed raised to positive 5. That becomes the derivative of our function there. Now, looks very easy, but it's good if you're very keen to make sure that you don't make a mistake, especially when it comes to these powers right here. Again, the procedure is very easy. You take, if you have the function of y equals to u power a, then you're going to multiply a by the function, and then you rewrite the function again, but now in the power you minus 1, and then you find the derivative of the function, what that is in the brackets, and then you multiply, then you expand or you simplify further. That's how we can solve or we can differentiate a function using the chain rule.